Hello, this is a test review for stoichiometry and limiting reactants problems, and in this video we'll cover four things. First is how to identify the given and unknown info provided in a problem. Second, we'll show you how to use that given and unknown information with the stoichiometry diagram to solve stoichiometry problems. Then we'll review the steps on how to complete limiting reactants problems using stoichiometry. And finally, there'll be an example limiting reactants problem broken down step by step. And overall goal of this video is to provide an interactive experience while going through this problem, and you'll see that as it comes up. So first, let's talk about how to identify the given and unknown. Here's three example problems. It's literally just grabbing information from the word problem. These three examples here are just plain stoichiometry problems. There's no limiting reactants. So how many moles of hydrogen are needed to completely react with 2 moles of hydrogen? The given is always the number that you're going to plug into whatever math you're doing, whatever equation you're going to use. So it tells us 2 moles of nitrogen, and the unknown is what we're trying to solve for, moles of hydrogen. Alright? I'm going to show you an example of 3 more problems that are just stoichiometry. Pause, take a look, and see if it makes sense. Alright, so here are some limiting reactant problems. This is how you'd write the given and unknown for these. So if 30 grams of NH4NO3 react with 50 grams of Na3PO4, how much of NH4,3PO4 can be formed? So the given are the two amounts of grams, 30 and 50. The unknown is the grams of the product NH4,3PO4. Okay? So we need to know how to do this to do the next step. So if the given in a stoichiometry problem is the mass, you can use the mass of the given to find the moles of the given, and you do that by dividing by the molar mass of the given compound. What if the problem, when you write down the given, gives you moles instead of grams? Well, you can use that number to find moles of the unknown that you wrote down, and to do that, you divide by its mole-to-mole ratio. That comes from the balanced chemical equation. If you start with a given with the moles of the unknown substance, and you want to know the grams of the unknown substance, then you just multiply by its molar mass. Alright, and here's a summary of the stoichiometry diagram. This is just the same diagram I've been giving you, just in a different shape. A little bit more of a pathway shape. And I'm going to use this in the example a little later on, okay? So before we hit the example, let's talk about just the steps for solving limiting reactant problems. Read the problem. Saying it seems like a silly first step, but there are quite a few students who do not do this. You're going to identify the given information first. And for limiting reactant problems, this is going to be in grams for both of the reactants, like in the examples earlier. Next, you're going to identify the unknown. What do I need to solve for? What am I trying to find? And this is probably, most likely, going to be grams of one or maybe both of the products. Alright, so you know your given, you know your unknown. Look at your balanced chemical equation and pick one of the products. It really doesn't matter which one. You'll still be able to find the limiting reactant. Alright, so you'll take your given grams of each reactant and convert it to grams of the product that you chose in step 3, and that conversion is a stoichiometry problem. Alright, once you have the amount of grams of product each one of the reactants would make, you would know you would pick the limiting reactant by looking at the given reactant that converted to the least amount of product that you chose. And you always use the limiting reactant to solve any additional stoichiometry problems like parts B, C, and D that you saw in the practice limiting reactant problems. You use these to make those videos last week. Alright, let's do an example, breaking it down step by step of these 6 steps. Here's the problem we're going to go over, and here's the first step. Read the problem, identify the given information. So if 15 grams of C2H6 react with 45 grams of O2, how many grams of water will be produced? So our given is 15 grams of C2H6 and 45 grams of O2. That's step 1. Step 2, what is the unknown? What are we trying to solve for here? So mathematically, the unknown here is the grams of water. How many grams of water is going to be made when you combine 15 grams of C2H6 and 45 grams of oxygen? And there's also a B, C, and D component here. But once we get through the next step, those will be answered as well before we even get to the mathematical answer. So step 3, pick one of the products. It doesn't matter which one. The unknown wants me to find grams of water, so I'm going to pick water as the product that I'm going to convert to using stoichiometry. Alright, so here's the hard part. You're going to convert the given grams for each reactant to the grams of the product that you chose. So we have given grams for 2 reactants. 15 grams for C2H6, that's the first reactant, and 45 grams for O2, which is our second reactant. We're going to convert each one of those to grams of water using stoichiometry. Alright, so we're going to take this given information and use stoichiometry. Alright, so we have the mass of the given substance, and we want to find mass of an unknown substance. And these are the steps that we talked about earlier. Let's plug in for the first reactant here. So here's the balanced chemical equation. The first reactant is C2H6. I'm going to put in C2H6 here. And we chose to convert to water. So I'll add that here. So go ahead and see if you can convert the mass of C2H6, which is 15 grams, all the way to the mass of water produced. Here is the math showing how to do this problem. If you need help setting up this math, you gotta make an appointment to come see me before the test. So that is how you find the amount of water made if you burned all 15 grams of C2H6. What about the second reactant? So here's my balanced chemical equation, and I have oxygen as our second reactant. So just like before, I'm going to replace the given and unknown with the actual compound. And I'm going to follow these mathematical steps to find the grams of water made by burning all 35 grams of O2, 45 grams of O2. And here's the math. Alright, so step 5 is the given reactant that converts to the least amount of the product you chose is the limiting reactant. So in the last slide, we had 21.7 grams of water made by burning all of the oxygen, all 45 grams. And then for when we burned all 15 grams of C2H6, that made 27 grams of water. What that means is when you compare the 27 to the 21.7, is that the oxygen gas, the grams of oxygen gas are going to run out before C2H6. So our limiting reactant is oxygen. That's the one that's going to run out first. The excess reactant is the one that's going to have leftovers when O2 runs out. That's C2H6. And to find our answer for A, we did that. If 15 grams of C2H6 reacts with 45 grams of O2, how many grams of water will be produced? Well, step 6 tells us that we use the limiting reactant to solve any stoichiometry problems. Well, we did that. We did a stoichiometry problem to convert from our limiting reactant of 45 grams of O2 to grams of water, and that gave us 21.7 grams. We're almost done with this problem. So always use the limiting reactant to solve any additional stoichiometry problem, and that's what part D is all about. how many grams are in excess at the end of the reaction? So how many grams of our excess reactant are left over after we burn up all the oxygen? So it's another stoichiometry problem. So fill that out and we'll replace. So we're going to start with our limiting reactant and we're trying to convert to grams of our C2H6. We want to find out how much of the C2H6 was used when we burned all 45 grams of O2. And that will be the first step towards finding the amount of leftovers. Here's the math. So we use 12.1 grams of C2H6 when we burn 45 grams of O2. To find out how many are left over, we write down how many grams of C2H6 we started with, 15, subtract the amount of grams we used, 12.1, and our leftovers are 2.9 grams. Okay, and that's how you use that stoichiometry diagram to help you solve limiting reactant problems.